Welcome to the first day of reInvent. Might be many of your first session. It's my first session of the event, so excited to be here with you all. Thank you for diehard infrastructure code fans coming all the way out here to be with us today. So I'm Ben Perrick. I'm part of the AWS Infrastructure as Code product team. With me I have James Hood, who's a PE on the team, and also Nick Xiao, who's a staff engineer with Netflix, who's going to talk a little bit about some of the exciting things that they have going on using some of our layers of infrastructure. So actually, before we get into this slide, I have a little admission here. You all came to reInvent, you came to this session expecting top-notch speakers, and what you got today is an understudy. So full disclosure, the person that was supposed to give this talk fell ill over the weekend. So I am the understudy. It's kind of like going to a sporting event and not having your favorite player playing, but I'm gonna do the best I can. We're gonna have a lot of fun. So let's dive right into it. Infrastructure as Code, hopefully you all are familiar with it, but for those of you that may just be interested in learning what it is, it's basically what the name says it is. You just declare your infrastructure using code. So in this simple example, I want to create an S3 bucket. I'm going to give it a simple name, maybe a tag. Then I'm going to throw it on my infrastructure as code tool, which is basically just a really big orchestration engine. It's going to look and see what type of APIs it needs to call to provision that infrastructure, and voila, we have this nice log bucket with a little tag type to it. So essentially, infrastructure as code is just going to do all of the heavy lifting to apply your desired state configuration. I think you probably all know that, but figured we'd just give a quick refresher of what we're talking about today. So the majority of the talk today, it is a year in review, so we will be focusing majority on the things that we've launched this year. But we also want to just cover a little bit of what we have to offer. AWS Infrastructure as Code, it's more than just CloudFormation. Many of you are probably familiar with CloudFormation, so we want to give a little recap of all the different tools that we offer. Spend a lot of time talking about the fun things that we launched this year. And we'll give a little glimpse into some of the things that we're thinking about heading into next year. So what tools do we offer? This is a bit of an eye chart, but we like to look at it kind of from a layer. We presented this in a couple different ways in years past. At the bottom, obviously, we have all of our different AWS services, 200 plus services. A layer on top of that is what we call the resource registry. We'll dive into that. Obviously, CloudFormation, kind of the workhorse of what is AWS IAC. And then we have a layer of abstraction on top, which are kind of dedicated tools specific for solving use cases. And then we actually launched this cool thing called Cloud Control API. We'll talk about that in a second as well. So when we look at what our IAC portfolio, so to speak, at AWS, this is kind of the way that we view things. We're going to start from the middle, we'll work our way out. So CloudFormation, like I said, it's the workhorse of infrastructure as code for us. It was launched in 2011. Initially, it was launched just out of necessity. Cloud came about, people needed to provision things, they needed to be able to replicate things. Manually authoring scripts became very challenging. And so it was like, hey, we need a better way of doing this, and that's essentially where CloudFormation came from. We started to add a lot of additional features to it to make it safer to deploy. So we do things like auto rollbacks, eventual consistency checks, et cetera. So making sure that we have these really reliable updates. And of course, people started to use it just like you would any other code. You start to version it, you put it in your version control systems, and you have this really nice replicatable infrastructure. We kind of think of it as the cheat code for cloud agility at scale. So you want to do things fast, declare your infrastructure using IAC, roll it out to all your different environments, rinse and repeat. So after CloudFormation, what we found was there was these like specific use cases that customers wanted to solve. And CloudFormation was great, but it was like, I don't really want to write that big long YAML file for my service application. So we came up with the service application model, and that's a dedicated CLI, a nice transforms, make it really, really nice to author your serverless apps. And then Amplify said, hey, we need a better way of building front-end mobile web apps. And so they built a whole layer on top of CloudFormation, made that really, really nice. If you're an Amplify customer, you happen to be a CloudFormation customer. And of course, we have CDK, which is a cloud development kit. We'll talk about that one. But there's a lot of others. So if you ever use Beanstalk, you're using CloudFormation. If you ever use Control Tower, you're using CloudFormation. Internally, we have services like SageMaker. Every time you spin up a SageMaker notebook, you're actually spinning up CloudFormation under the hood. So it's become really a powerful deployment orchestration engine across not only customer-facing services, but also internally as well. We're going to dive into CDK a little bit. So how many of you are familiar with CDK? That's the pattern we expected. Obviously, you're starting to see more and more people move to CDK. It's a really nice way of authoring your infrastructure. You can use languages you love, Python, TypeScript, You get the benefit of working in the environments you want with your IDEs and code complete and all this fun stuff. But it also has really nice modularity. So obviously constructs are a powerful component of CDK. They allow you to define kind of your best practices, whether it's a single resource with kind of canned defaults, or whether it's multiple resources, or even up to what we call layer 3, which is a whole microservice. Just make a really nice way of authoring your infrastructure. At the end of the day, for those of you familiar with CDK, it synthesizes down to a CloudFormation template and is deployed through CloudFormation. Now, that's CloudFormation, that's the layer on top. What about the layer below it? So at the bottom of this is what we call the resource registry. And this is really all of the individual resources. So a resource basically is just how you communicate with the underlying service. So at AWS, every time a new service or a new control plane API is launched, they need to have resource coverage support. We call it CloudFormation resource coverage on the registry, but I like to call it the AWS resource coverage on the registry. And the reason for that is more and more resource-centric tools in AWS are starting to standardize on this resource model. What I mean by that is, think of config, resource-centric tool for checking your configurations. They use the same resource model. Resource Explorer is starting to use the same resource model. We have some things coming out in Q that happen to use the same resource model. So you're starting to see the standardization of what AWS defines as a resource, really based on this resource registry. Just for a quick background, right now, we've been migrating a lot of our resources. If you come to sessions past, you've heard about this. We posted some blogs about it. What we're trying to do is migrate all of our existing resources onto the standard registry. Right now, we have about 97% of our usage on the standard model. So if you're diehard CloudFormation users, you may have noticed that support for things like resource import or drift detection has started to increase. Every time a resource is added to the registry, it gets support for all these other fun features like drift detection, et cetera. So really happy with the progress we've made there. And as we started to standardize that resource model, the only way that you would interact with it was using CloudFormation. You write a template, send it to CloudFormation, and we thought to ourselves, like, if we have all the standard resources, why not create an interface for that? And so that's what we did when we launched Cloud Control API. So Cloud Control API, it's just that, it's a control plane API, standard interface for how you interact with those underlying resources. So you want to know what IAM roles you have in your environment, you just say Cloud Control API, list IAM role. You want to know what a specific DynamoDB table looks like, you say Cloud Control API, read DynamoDB. So it makes it really nice to be able to build a lot of different use cases and automation on top of it. In fact, we called out some other third-party IC tools here because they've actually launched providers using Cloud Control API. So just this year, Terraform launched the general availability of their Cloud Control provider. And the unique thing about this is it's actually auto-generated. So as I mentioned, service teams have to launch a new capability. They launch it, they have to provide resource coverage. They build that using our standard model. It gets exposed through Cloud Control API, and all these tools just pick it up. So we're able to accelerate coverage not just for CloudFormation, but for tools like Terraform and Pulumi, and even internally config is starting to add a lot more resources because they're standardizing on that same resource model and using Cloud Control API. So really happy again with the progress we're making here. It's not just about this being CloudFormation. There's a lot to it. And again, the components matter a lot. And we're really excited about what we have going on with the registry and Cloud Control API. Cool. So let's talk a little bit about what customers have been asking for so we can get into kind of what we've been focusing on. So 3 main pillars. First is development. So this is all about how you author templates, how you deploy, how you dev test a template. Historically, we know CloudFormation may not have been the easiest tool to work. You deploy something, and it takes 20 minutes, and maybe it fails, it has to roll back for 20 minutes. Now, so we hear you, and we've been doing a lot of work to try to improve on accelerating that dev test from core engine improvements to reducing the number of failures to triaging failures, and James is going to talk a lot about those details. The second thing is safety, deployment. When you deploy your infrastructure, you want to make sure it's going to be safe. You want to make sure there's not going to be any production outages. You want to know that what you're deploying and the changes you expect to make are the actual changes that are happening. And so we focused a lot around how do we make sure that we have visibility into what the changes are to make these things safe. And finally, governance. So as more and more, and you all likely are standardizing on using infrastructure as code as the primary way of provisioning your infrastructure, it provides a great control point. So if you want to ensure that you have correct configurations, why not check them at the point of provisioning? And so we've done a lot of work here around giving the ability to write controls that check for configuration correctness, enforcing security and compliance best practices. So these have been our focus areas for this year. I'm going to turn it over to James. He's going to be able to go into a lot more detail into all of these different categories. James.
Thanks. Hey, my name is James Hood. I'm a principal engineer at Amazon. I've been with the company 15 years. Most of that time spent in AWS, but also working in retail. I was actually I've worked on the CloudFormation team about 5 years now, and I was a CloudFormation customer before that, even within Amazon for 5 years. So very passionate about this area. I wanted to talk to you about some various launches that we've had this year, and we'll start on the theme of development speed. So first, let's talk about increasing the speed of onboarding a project onto IAC. Now, if you're here in this talk, I'm sure you understand the importance and the value of IAC, but quick show of hands, who's ever created a resource outside of IAC, either through the console, through CLI, through SDK, right? Click happens, right? So we have so this may be a good way to start out. The console is a great way to understand new services, play around with them. Depending on the size of an application, or you're just starting out, trying out an application, you may create your resources manually through the console. But at some point, you'll reach a point where you want to migrate onto IAC, and that means you're going to have to manually construct this IAC template. And this is a major hurdle for IAC adoption. It's a highly manual process. It can be difficult to reverse engineer the exact IAC specification that matches all of the manual configurations that you made. So rather than having you have to do it manually, in February we launched CloudFormation's IAC generator, which does this heavy lifting for you. And it's meant to help you cross that chasm from ClickOps into IAC. So to use it, you browse through the catalog of resources in your account, and you can select the ones that you want to copy into your IAC template. The tool will also inspect those resources and identify other resources that may be related to them, so you can pull them in as well. For example, if you go to the DynamoDB console and you create a DynamoDB table, you may not realize it, but in the background it also creates alarms for you, and our IAC generator, when you select that table, it will automatically detect those alarms and ask you if you want to import those as well. So you can add these other required resources that you may have missed, and then the tool will generate a CloudFormation template for you and even offer to either import them in a brand new stack or even an existing stack that you already own. So IAC generator is our way of trying to help you to get over that initial hump of transitioning your projects onto IAC. Now let's talk about development speed. So I've been working in software for over 20 years. I've been working with developers. You never hear a developer, when you're in that tight inner loop of editing and testing and trying to get a change to the point where you're ready to put up a pull request or code review, you're never saying, I'd like to go slower, right? You want that inner loop to be as fast as possible. And the same holds true for IAC development. The inner loop when you're developing on IAC involves making edits to a template, provisioning it in a development environment to see if it works, troubleshooting any errors or debugging, and then repeating. And so the main components that can slow you down in that inner loop are the time that it takes to provision the template, the speed at which those errors are returned to you, and how long it takes developers to troubleshoot any issues. We've been focusing on all aspects of this inner loop and have some productivity improvements across each of them. So in the first quarter of this year, we announced that we improved stack creation times by up to 40%. One of the things I love about coming to reInvent as an engineer is, ever since the start of reInvent, at its heart, it's a learning conference. We have, raise your hand if you're in engineering or DevOps or that area. Yeah, so majority of participants. And so I love coming here as an engineer because I can spend some time diving deep into some of the details about how we were able to achieve this. So this improvement was the result of a fundamental change to our deployment strategy that increases parallel creation of resources. So even prior to this change, CloudFormation created independent resources in parallel. So for example, if you create a stack that contains 3 independent SQS queues, CloudFormation will deploy them in parallel. However, resources declared in the template can have dependencies on one another, on other resources. So here we have an example of a containerized application containing multiple resource dependencies. You can see that the ECS service resource depends on the ECS task definition, the ECS cluster, and the VPC networking resources. Also, the ECS task definition depends on an ECR repository. So when CloudFormation deploys these resources, it can start deploying both the ECR repository and ECS cluster in parallel since they're independent. However, it must wait for the ECR repository provisioning to complete before it begins deploying the ECS task definition. Similarly, it must wait for the ECS task definition to complete before it begins deploying the ECS service. You can see how these dependency chains have a direct impact on stack creation times. So how do we speed this up? Well, it starts by taking a deeper look at what's actually happening during the provisioning of individual resources. So let's take IAM role as an example. You may notice that if you create an IAM role in the AWS console, or you call the create role API via the CLI or SDK, the API returns on average in sub-second latencies, very, very fast. However, when you provision using CloudFormation, it takes longer. So what's happening? What's going on? So CloudFormation's accounting for eventual consistency within the IAM service. There's a difference between when the create role API returns in this sub-second latency and when the IAM service has performed additional asynchronous activity that in the background that makes it so you can actually use that role, like assume that role. And there is a delay in this. So in general, we can break up resource creation into 2 key milestones. The first one we call configuration complete. And this is where, if you call that get role API, it's going to reflect back the change that you wrote. And then this generally happens really quickly after you make the initial API calls. However, CloudFormation waits an additional period of time for the role to stabilize, meaning the asynchronous work is completed and the resource is now ready for use. So if we distinguish these milestones in our timelines, we can see that CloudFormation was taking a very conservative approach, waiting until a resource was fully stabilized before continuing to the next dependent resource. However, a key insight was that frequently it's not really necessary to wait until the resources achieve that full stabilization to proceed to the next resource. And we can instead wait till we reach that configuration complete milestone and then optimistically start creating the next resource. We call this deployment strategy optimistic stabilization, and it looks like this. So you can see with this new strategy that we start provisioning the ECS task definition once the ECR repository is configuration complete. Similarly, we begin creating the ECS service as soon as all of its dependencies have reached at least configuration complete. This results in a higher level of parallelism, reducing the overall time during stack creation. Since this is an optimistic strategy, by definition, we do have to handle the case where trying the next resource too soon fails. And it looks like this. So if we encounter an error on a resource we've optimistically tried to provision early, we simply wait for the dependent resources to fully stabilize and then retry the operation. Here you can see the ECS service failed on the first attempt, so CloudFormation waits until the ECS task definition has reached that full stabilization point and then tries one more time. Note that even in this error case, it's still possible to experience some time savings. The time savings depends on the length of this resource dependency chain and whether the optimistic creation attempt was successful. One other thing I wanted to note is that we not only changed this deployment strategy behind the scenes, we also added new stack events and a detailed status field so that customers can see when resources reach this configuration complete status. We did this to try to give you better visibility into the stack provisioning process. And we also added this detailed status at the stack level as well. For backward compatibility reasons, we need to maintain customers' expectation that when the actual stack operation completes, that all the resources have fully stabilized. But we wanted to surface this configuration complete at the stack level, which means that all of the resources in that stack operation have reached at least that configuration complete. Because there are some use cases, maybe if you're in a rapid dev test cycle, where you may want to just pull for that configuration complete and move on even more quickly. So you can see here that if you monitor for stack configuration complete in the previous example that I showed, and then, for example, you use in the CLI, you're just polling for this detailed status at the stack level, that you could see even bigger time savings. And again, it depends on your use case of whether this applies. Some tools like Amplify, for example, their CLI, they've automatically integrated this in for situations where they know you're just in this tight dev test inner loop. So yeah, this is one thing that, again, I love digging into the details of this, but it underscores kind of the value of AWS managed services. We did this work, and this was a fundamental change to our core engine. We deploy a lot of stacks every week, and we had to roll this out very slowly over a period of many months, but we were passionate about wanting to be able to give customers this speed up benefit without them having to do anything special, without them having to opt in, right? And so I just want to call out, as much fun as it is for me to come here and talk about it, as a customer, hopefully you see the value of having these teams of engineers behind the scenes trying to just make your life better without you having to do anything, really. Also, as much as I like to draw timelines in PowerPoint, we thought, wouldn't it be nice if we could just show you the same timeline? So I think just about a month ago, we launched this new timeline view in the AWS console. So you can actually see this timeline in real time. It gives you more visibility into the stack operation, orchestration. You can understand what resources are being provisioned and the dependencies between them. So we really hope this gives you better visibility into your stack operations so you can better understand its dependencies and processing times. It hasn't been out for very long, and we've actually seen a lot of customer response to this and customers leveraging this. We've even had some fun anecdotes about customers not realizing that they could actually modify their template to better optimize their own deployments. All right, so beyond raw provisioning speed, there are other things that help to accelerate the iterative development test cycle. So one is catching errors faster, so developers can start fixing them sooner. Sometimes you might set a resource property to an invalid value, and then you forget to set some required property, and you don't discover this until late in the deployment cycle when it's actually trying to deploy the resource, and then you have to wait through a rollback, and it takes extra time. So this year we started adding checks for common template errors early in the process before we've started actually trying to deploy. And from these changes, we were able to achieve like a 6.2x faster error response time in the median case and 17x faster in the P90 case. Another quality of life improvement we added, so we have a feature called custom resources. This allows you to create your own resource and run your own code and manage your own resource. And we had a default timeout on custom resources of 1 hour. And what that meant was, as you were developing a custom resource, if you had a bug in your code that caused, let's say your custom resource is backed by a Lambda function, and your Lambda function throws some error before being able to respond back to CloudFormation, now you have to sit and wait an hour for CloudFormation to time out, and then maybe another hour for it to roll back, right? And that really slowed the dev test cycle. So we added configurable timeouts to custom resources. So you can set, if it's a Lambda function that should finish very quickly, you can set a timeout of 5 seconds, and then you're not waiting that long time. We're also helping developers to troubleshoot errors after they receive them. So one thing that we provided was, last year we launched this detect root cause or view root cause button that quickly takes you to the root cause. And if you remember from what Ben was talking about, our resource layer is kind of an abstraction over the AWS APIs. For example, the AWS S3 bucket resource type is really an abstraction over many API calls. It could make many API calls when you're trying to do a create or an update. And we got feedback from customers that it would be really nice if in certain troubleshooting scenarios, they have to go to CloudTrail to see what the actual underlying API calls were and what the detailed error messages were. So we added a feature to take you straight to that timestamp in CloudFormation, in CloudTrail, so that you can look at those events very, very quickly. We also just launched a feature called Diagnose with Amazon Q, and this is where that root cause error, you can open up a dialog with Amazon Q, and it can offer you more of a human-readable explanation of error messages, and you can even click a button saying, help me resolve, and get suggestions on how to resolve your CloudFormation error. And finally, I wanted to quickly highlight some of the many tools that you all can use to boost your productivity when authoring templates. The first is the CloudFormation linter tool, CFN-lint. How many people use CFN-lint, first off? Okay, so not that many. CFN-lint is a massive time saver. It was a game changer for me when I first discovered it, and we just launched a GA version of the tool this year. It essentially can correct, you can run it over your templates and it'll return errors and warnings before you've even deployed, and it can catch many errors that you wouldn't catch until deploy time. It's also such a popular tool that we offer an IDE plugin, so you can also have it plug into your IDE, and it can detect errors as you type in your IDEs. CloudFormation Rain is another useful CLI tool. It assists developers through workflows of authoring and deploying templates. You can use it to do things like format and beautify your templates, package local artifacts into a template, and get an interactive deployment experience with real-time updates. And finally, the last tool I'd like to highlight is Amazon Q. That's our generative AI-powered assistant, which you can use either from the AWS console or from IDEs. So it's supported in VS Code, in JetBrains, and yeah, if you haven't tried this tool out, it has a really nice integration with IAC templates specifically. It can generate a brand new template in the IDE. You can highlight sections of your template and ask Q developer to explain what this section is doing, or even do edits to parts of your template. For example, if you have a SNS topic that you've created without many properties on it, Q developer will actually tell you, hey, it's recommended, best practice is to have a customer managed KMS key to encrypt the data on this SNS topic, and you can highlight that topic and you can say, add a custom KMS key, and it'll add the key for you in the template and add it to, and reference it from that topic. Okay, so I know we had a lot of CDK users raise their hand at the beginning, so I did want to talk about some CDK launches this year to improve the experience. So first off, a new L2 construct was launched for VPC with subnet configuration. VPCs were the number one most used construct that didn't have an L2 construct. So for those not familiar, CDK has different levels, and they call them for short L1, L2, L3. L1 is just the raw CloudFormation layer, CloudFormation resource layer. And L2 is a more developer-friendly ergonomic experience over different resources that you can provision in your stack. And so they introduced an L2 construct for VPC, and it's offering the convenience of L2 constructs, but with the full configurability of and power of the underlying VPC resources. We also launched the CloudFront construct with origin access control. This allows you to create origins for a CloudFront distribution from S3 buckets or ELB v2 load balancers or any other domain name. And it was the most voted new L2 request from CDK customers, so that's launched. We also have 2 new L2 constructs that are in developer preview. One for Kinesis Data Firehose, which allows you to define Kinesis Data Firehose delivery streams, as well as Cognito identity pools, which enable you to grant your users access to other AWS services. Finally, we had some quality of life improvements. So CDK has this concept of assets. This could be either S3 objects that hold Lambda function code, for example, or ECR container images. And we added garbage collection of older assets that are not used anymore that were just taking up unnecessary cost for customers. So now you can configure that to be auto cleaned up. Also, there was issues where if CDK would assume a role, IAM role, that if the deployment took longer than 1 hour, that session could time out. And the CDK team has addressed this with IAM role session tags for supporting these longer deployments. Okay, so that was all on deployment speed. Now we're going to talk about deployment safety. So that inner loop, the speed is really, really important. However, once you get to that outer loop where you're actually deploying to production, then safety becomes paramount at that point. So validation tools like CFN-lint help to pre-validate that your templates are syntactically correct before provisioning, but it's not always clear exactly what specifically will change when you actually deploy. So rather than perform a stack update and hope that everything goes okay or goes as planned, CloudFormation has this notion of change sets, where you can create a change set that's going to give you a set of changes that will be made, and you can review those before actually doing the deployment. Now, previously, CloudFormation, we've had change sets for a while, but previously they really just showed you at the resource level that a resource will be added or modified or removed, and didn't give you a whole lot of detail on top of that. So in the second quarter of this year, we launched enhancements to our change sets to show before and after values of resource properties and attributes. So I wanted to walk through a specific example so you can see why this is important, why this is helpful. So here's a snippet of CloudFormation template code where I'm provisioning a Lambda function, and I want you to note that some properties have specific values like the handler or the function name. However, others are dynamic values. So this function's memory size is a reference to a template parameter, which can default to a value of 128, but can also be overridden at deploy time. Also, the function's runtime is populated by a dynamic reference to a SSM parameter value. So if I just submit, let's say I submit this template as a new change, and then I'm looking in my source control and I'm looking at the diff. It could look something like this. For example, if I look at just this source code diff, then I'm expecting the runtime property to change and the role property to change. But it doesn't show me how these dynamic values are going to be resolved by CloudFormation when it deploys. So let's see what the change set says to see the difference. So what we see in this example is that the change set is actually quite different than what we expected. The runtime property did change, but with change sets, we can see exactly what value it will change to. The role property actually did not change, even though the source changed, but that's because the getAttribute intrinsic function that we added ended up resolving to the same value. And then we can see that our memory size property is changing even though we didn't even modify it in our template source. So this could be because, for example, the value, it comes from a template parameter and maybe that value was changed by accident since the last time that we deployed. So this, I wanted to illustrate why change sets are very powerful and they can give you confidence to know exactly what that deployment is actually going to change. Also, last year we launched Git Sync integration, which allows syncing direct from Git providers to CloudFormation. And as part of these change set enhancements, we recently launched the ability to automatically post change sets into your pull request comments. So you can create a pull request, and then behind the scenes, we'll automatically create a change set and post it to your pull request as a comment so that the reviewer can have confidence in what exactly is going to change before approving and merging that pull request. So I wanted to take a moment to showcase some of the interesting customer use case of change sets. And in this case, the customer is actually Amazon itself. So CloudFormation is the de facto standard tool internally in Amazon for deploying all AWS infrastructure. And the CloudFormation team partners very closely with the internal Builder Tools team, and they create tooling for the internal engineering teams to use to build their software that powers Amazon businesses. Now, operational excellence has always been a top focus at Amazon, and we're working with the Builder Tools team to experiment with new innovations for safe infrastructure deployments. And one key project we've been working with them on this year is called Change Guardian. And Change Guardian is a tool that runs a set of rules against the CloudFormation change set in order to flag potential high-risk changes and either block those changes or ask for acknowledgement. So they're able to run these rules and identify potentially dangerous changes. For example, accidentally deleting stateful resources that may be holding data, or even security related, like accidentally creating a bucket with public access. So these tools, again, we work in partnership, and one of the nice things about being on the CloudFormation team is we have this customer that's been using us for so many years that's really close to us, right? We're part of the same overall company, and so we have a lot of unique insight into outages that have been caused by accidental, maybe deletion of in-use resources, those kind of things. So we're experimenting with these rules and internally, and then as we collaborate on these internal experimental features, then we're planning on taking the best ones and adding them to CloudFormation so that all of our customers can benefit from them. All right, so I'm going to hand things back off to Ben at this point, who's going to talk about some of our new launches for governance control.
All right. This one I don't have to be an understudy on because I actually launched a lot of these, so I know them well. Okay, since the dawn of cloud, this has been the trade-off that you all have been going against. Do you give developer freedom and agility and move fast, or do you implement control? So curious here, if we were to raise hands, how many of you are on the let's go fast developer like agility front here? Okay, how many of you are like, no, we got to have controls, everything has to be correct? All right, so that's the split. So the tug of war is real. We've seen a lot of different patterns for how customers have tried to address this. One of them is this golden path. How many of you have a golden path, like you vend out best practice templates or constructs? Is that a common pattern here? Yeah, a few of you. So the thing with this is it works really well to allow your developers to go fast. You say, here's the templates that you can use. They're pre-approved. If you use them, you can just deploy them. Here's your constructs. Here's your modules. Go fast. That works well until you have nuances where it's like that pattern doesn't meet my needs perfectly. And there becomes this bottleneck of how do you then handle customizations to the golden path. The other pattern we see a lot of course, is a detective control approach. So let things get provisioned and we'll pick them up after the fact. And of course we know like this is a good way of detecting misconfigurations, except for it's oftentimes require a code change to remediate. So it's pretty expensive when you find these things, timelines, and maybe you have to do some sort of a deployment period or outage or something like that to make the changes. You have developer time spent doing these changes or misconfiguration remediations. So it's just a little bit too late and it's a little too expensive. So the way that we like to address this is through a feature we call CloudFormation hooks. So think of CloudFormation hooks, if you're not familiar with it, it's a control point in the CloudFormation service. So you say, CloudFormation, anytime you see a DynamoDB table, stop, check the configuration, make sure it meets my best practices, and if it does, you can go ahead and continue. If it doesn't, then don't allow that to happen. And so we see this as a really powerful way of doing these proactive checks and enforce your best practice configurations. Again, I mentioned a lot of you are standardizing on infrastructure as code as your primary way of deploying, so this becomes a really good way of enforcing those proactive controls. So we launched hooks, I don't know, about 18 months ago, and what we found was the authoring was really hard. Feedback we got was, love the primitive, don't like the developer experience. So this year we focused on how do we make it easy for you all to write hooks. And so the first thing we did was allow you to write a hook that just points to a Lambda function. Writing a Lambda function is a pretty common pattern with our customers. So the way that this works is you say, CloudFormation, anytime you see a create S3 bucket or create IAM policy, whatever it is, you just say, run my Lambda function. And we send you that resource payload, the fully resolved resource payload, so it doesn't have any intrinsic function values or anything like that. You get the fully resolved resource. It goes to your Lambda function, and your Lambda function gets to evaluate it. So a lot of our customers have like a policy engine internally anyway. So all they need is what is going to be provisioned, and then they send back whether they like it or not. So this is what we call an AWS managed hook. It's the AWS managed Lambda hook. This hook happens to be a no additional charge hook. Of course, you get charged for Lambda, but you don't get charged for the actual hook invocation here. So really easy way of authoring. The second one is we have a policy as code tool called CloudFormation Guard. So if you're not familiar with it, it's just an open source policy as code tool. You write your declarative language, your domain specific declarative policy, and you scan a CloudFormation template, and you can determine whether you have rules that pass or fail. So to simplify how you can author the hook, we allow you just to throw a set of guard rules at it. So we have lots of good guard rules out. There's an open source guard repository. Control Tower has published like 250 plus really good managed controls using guard. So now you can just go take those guard rules, you throw it in an S3 bucket, and you activate the hook and say, run these rules whenever this type of resource operation happens. So again, this guard rule comes at no additional charge. So really, it's an easy way for you all, those that raise your hands on the configuration correctness piece of things, to be able to go and implement these proactive controls to check how those configurations meet your company best practices. Now, historically, we had what we called resource hooks. This would run right at the time the resource is about to be provisioned. So James walked through kind of our orchestration engine and said, okay, it's time now to provision this queue. And we would stop and run the hook. And that was good because it gave you a fully resolved resource. But what we heard from customers was we'd actually like to evaluate multiple resources at once, or just evaluate the whole template. A lot of you all have template scanning solutions already, and rather than having to manage that during your pipeline, you'd prefer CloudFormation to manage it for you. So we introduced new types of hook invocation points. The first one is Cloud Control API. We talked about what the Cloud Control API is. It's a new interface. It's a new way of interacting with these underlying resources. We talked about, we launched a new provider for Terraform and Pulumi and Ansible. All of those resource mutating operations go through Cloud Control API, and now we extended hooks to that. So now, just like CloudFormation, you can extend your proactive checks to Cloud Control API. In fact, it's the exact same resource. It's the same payload you evaluate. The next ones we launched was a hook for stacks. So this time the payload, you run the hook, you get the entire template. So this is a nice, powerful way of, if you have an existing way of scanning your templates and you don't want to run that or managing your own pipeline, you can just run that as a hook now and have it as more of a service managed hook. So this means anytime we get a create, update, delete operation, your hook can get the entire template payload. The one I'm most excited about is actually change sets. So James went through a lot of detail about how we're enhancing change sets to give you a lot of visibility. Common pattern is do your deployment, create a change set, do some sort of a review on that change set, and maybe your operators have a run book that says, check that we're not deleting a DynamoDB table. And now we allow you to run hooks on that change set. So you can actually automate some of those steps. So you can create a change set, you can do any of your standard automated validations against that using a hook, and accelerate that time to review. So really excited about that new invocation point. So overall, 2 new managed hooks, easier authoring, and then new invocation points for Cloud Control API, stack, and change sets. We're really, really excited about these capabilities. We're going to continue to innovate on these. We have a whole new console design, so if any of you have been to the CloudFormation console recently, we've kind of up-leveled hooks to a higher level on the navigation pane. Really nice workflows for how you can go and play around with these things. So these were just launched a couple weeks ago. Please go take a look, have fun with them. Again, you can use the managed hooks. There's no additional charge for them. You can actually run hooks in different modes to be able to kind of ease into them, and one actually I want to talk about, a customer that's doing that. So Cox Automotive, if you're familiar with Cox Automotive, they've been all in on AWS for a while now. They have really nice tools like Kelley Blue Book and AutoTrader, and they were looking for ways to be able to kind of accelerate how they could do these proactive checks. They have a robust detective scanning solution, and they came to us and said, hey, this is expensive for us. You know, we need a better way of doing that. And so the approach that they take, which I really like, it's a very methodical, easy approach. They look at their most common detective control failures, and then they say, okay, well, let's figure out how to make this a proactive control. And they take that same rule, they turn it into a CloudFormation hook, and what they do is actually they set it up in a warn mode. So hooks have a hard fail or warn mode. So now, instead of completely interrupting your deployment pipelines and your application teams with a hook that suddenly their CloudFormation deployment breaks, they're able to say, let's turn on these hooks, let's learn what's happening, have them in failure mode. We're not disrupting operations. We're just seeing how frequently we have these violations. We implement a nice change management process. We notify our teams that, hey, in 30 days from now, you're going to start to have this operation prevented. Therefore, you won't have any more of these detective control violations. And so it's a really effective way for them to be able to go from just a detective control approach to a proactive control approach without completely disrupting their business. I really like what they're doing. Okay, now, finally, Nick's been waiting here patiently. We're excited to announce, bring Nick up here. Nick, as we mentioned, is a staff engineer from Netflix, doing some really innovative things, not only with, well, actually I should say not at all with CloudFormation, but actually looking at some of the underlying layers of capabilities that we talked about earlier. So, Nick, I'll turn it over to you. Oh, you have one.
All right, is this mic working for people here? All right. So hi, my name is Nick. I'm on the cloud infrastructure security team at Netflix, and we've been using Cloud Control really heavily for kind of a couple of things lately, but one project in particular, and we found a lot of value out of it, and we've unlocked a lot of value, especially from like the ISE ecosystem that AWS provides, specifically through it. So to provide a little bit of background of infrastructure management at Netflix. We like to take services and platforms and basically wrap them in abstractions wherever possible. We believe really strongly in kind of the golden path, or what we call like a paved road approach. So for a lot of the services that we use, we put a layer or an abstraction or a UI in front of engineers, and that's kind of how they access or manage their infrastructure. So for IAM specifically, we have an open source tool that is called ConsoleMe, and it manages the vast majority of IAM changes at the company. For all things EC2, so your compute, your storage, your networking, all of that, we have another open source tool called Spinnaker, and most people will go through Spinnaker to make these changes. And then we kind of don't have anything for a pretty large swath of services. So we make heavy use of what we call kind of like these core cloud infra primitives, things like S3 buckets, SQS queues, SNS topics, DynamoDB tables, everything like that. And we kind of saw this missing piece of not really having a paved road for a lot of these services. And so we delegated that to engineers. Some of them used the console, some of them used tools like CloudFormation or occasionally Terraform, and it kind of saw their own way through it. So we wanted to find a way to take a lot of our opinions and best practices, especially from a security and infrastructure perspective, and offer that in a self-service way to users. So our goals here were a pretty minimal paved road. Like we knew we wanted to do this for a lot more service types, and we knew that that was going to be harder and harder to scale, especially from the position of a small security team. And we also wanted to build this into existing experiences. So we wanted to do this in a way that felt very Netflixy. We didn't want to rebuild the AWS console, and we definitely didn't want to rebuild AWS CloudFormation from scratch. So we came up with a solution that we call Managed Cloud Resources, and this is something that uses Cloud Control API under the hood really heavily to manage a broad and growing number of resources. So now I'll give a kind of quick demo of what this looks like. All right, so starting off, we're going to be looking at an IAC template, and so this is kind of a Netflix flavor of it. Here we're creating a new S3 bucket. We're doing it in a test account in one region. We're giving it permissions to an app called example app to read out of the bucket. And that AWS piece at the end is probably the most interesting here, which is we're saying a lifecycle configuration and tags. So we're going to go ahead and commit this and then push it up to source control. All right, so once that's there, we're going to go look at an internal UI called Spinnaker, and we'll see that this resource is now in an updating state. So what this means is we call it a reconciliation process, and behind the scenes, we're making some changes and we're passing things off to Cloud Control API to figure out what it needs to do with the resource to take our configuration and make it active. So if we go look at the bucket here, first of all, we'll see that it constructed a new name for it, adhering to our best practices. It also added a large number of tags to it. So we see the tag that we specified here, but additionally a bunch of other tags that help us get an idea of what this bucket's going to be used for and have a lot of metadata and rich context around it. We'll also see that even though we didn't specify a bucket policy, it generated one. And this uses kind of a tag-based ABAC approach to give access to this example app that we mentioned previously. And allow the owning app to basically access anything inside the bucket. Over on the management side, we'll see that the lifecycle policy that we specified was also present here. So how is this built? How does this use Cloud Control API? So this is integrated with an in-house Kubernetes platform called Infra API. And similar to what Ben mentioned earlier, we take that CloudFormation registry, so those standard models, and we generate Kubernetes resources. So we take a schema and turn it into something that Cloud Control API can understand, but also that we can use internally. The developer workflow looks really similar to any other IAC tool you'd kind of see, where you have the developer starting with a YAML template. Then our team specifically is doing a lot of different checks and tweaks. So we're performing authorization. Should you be able to do this on this resource? We're applying a series of secure defaults, so our opinions about how these resources should come up. We're checking the configuration, and then we're auto-generating a bunch of the attributes that you saw. We're then passing that off to CC API, which is then doing the work. So one thing that's of note is through the entire process that just kind of walked through, we don't have any code that knows how to set lifecycle configurations or specifically tags or how to create a bucket. We're kind of taking this developer intent, packaging it up, and then handing it off to AWS to do things with it. So why CC API, or why did we kind of land on this as a technology choice? Honestly, a bunch of reasons. The first is the coverage aspect. So we knew that we wanted to do this for a bunch of new resource types, and then also more in the future. And so we wanted to standardize on something that was AWS native and would quickly get support for new resources, new attributes, that sort of thing. We also wanted to build a really customized experience, and Cloud Control, the fact that it's made up of some of the building blocks of CloudFormation, let us do that. So we have certain constructs that didn't really work well with CloudFormation, namely things like stacks, also having to import resources to CloudFormation or export them out later. So we found that with CC API, we can get around most of that. We can define our own constructs, our own semantics, and the process for moving a resource from it was just made in the console or it was made separately into IAC management was really straightforward. There's no concept of like a stack state, nor anything like Terraform state. We also saw a lot of powerful features in the CC API ecosystem that we wanted to use. So drift management was a big one. We wanted to detect drift and remediate it in some instances, exactly kind of how we wanted to. And we also want to introduce a lot of controls. So that sort of middle part of the workflow where we want to step in and basically sit between every resource creation and every resource mutation. We saw a big opportunity to take some of these decomposed building blocks, build that position for ourselves, and then exert a lot of opinion over how these resources are created and managed. So overall, it's been a very powerful new tool in our toolkit. Using it for this and kind of finding fun new use cases for it elsewhere, we're able to build these new experiences for infrastructure management with a small fraction of the code that it would take otherwise. So if some of these problems resonate with you, if you find yourself building ISE solutions in your company, we'd recommend you check it out. I'll hand it back to Ben.
All right, almost there. I told you we'll go through what's next. Thanks, Nick. I think it's really neat to show, like, we're not just stuck on CloudFormation. We saw the need of being able to expose this resource layer. We created this interface for it. It's opening up all these really exciting new use cases that we never thought about when we were first launching CC API. It's pretty exciting, so appreciate the partnership. All right, what's next? So we're going to continue focusing on these 3 core areas. We're going to continue to try to make things faster. We're going to try to continue to make things safer. And of course, we're going to continue with the governance and control. So you can count on us. Features that we've launched this year that we talked about, we're going to continue to innovate on those. But the thing that we think is interesting is around, we talked a little bit about being able to have the standard resource model, which allows us to be able to consistently read into your environments and see the configuration of resources. Traditionally, the way that you interact is you go one direction. You create a template, you send it to CloudFormation, and it provisions those resources. And in a purist state, that works great. If only thing you do is use CloudFormation, then that's fine. But as James mentioned, drift happens. People do things for different reasons. Sometimes you have to go to console, sometimes you have an emergency bug fix, and so changes happen. And so I think the direction we're looking at is how do you have this bidirectional kind of fluid management of resources? So what if someone has to go to console and makes a change and we can identify that change in real time and suddenly CloudFormation recognizes that change happened and then it says, hey, change to your template, your desired state just happened. Is this what you want? How do you want to remediate it? How do you want to pull these things back into sync? The direction we're going is really only possible because we now have this common resource layer, common way of being able to list and read into your environment, common way of being able to identify changes to those resources that are under management. So directionally, this full lifecycle resource management is an area that we're really excited about, kind of blurring the lines between just this pure CloudFormation template or ClickOps. Like now we think that we'll be able to have this really nice blurred bidirectional thing. We still recommend only going through CloudFormation as the primary way, but we're also acknowledging that things happen outside of CloudFormation, and when they do, it's very painful for customers to be able to get those things back into a state of sync. And so directionally where we want to go is to have this very blurred line, kind of nice experience between I'm doing something ClickOps, maybe I don't want to, but I did, and now it's seamlessly integrated back into your CloudFormation template. CloudFormation can recognize it. CloudFormation can help you get back into sync really quick. So expect some things from us next year in that area. A lot of drift management type of capabilities. And with that, we've got a lot of helpful resources. So we have workshops. Check it out for CloudFormation, for CDK. We also have a Discord channel that we like to try to draw some engagement from. Of course, CDK Slack channel. A lot of good open source discussions happening there. And with that, just want to say thank you. Appreciate it. We're right at time here. Have a wonderful, wonderful reInvent. I know it's the first day. Keep those feet comfortable. Drink lots of water. And we'll stick around here for a few minutes if you all have any questions. But thank you. Appreciate it.